Okay, so now we're going to talk about cosine. In this video, we're going to do some other graphs today as well, but this video is just going to be cosine. So if we can understand the sine function and how to graph the sine function from an equation, how to come up with an equation from a graph of a sine function, then we should be able to do that for cosine as well, because they're very, very similar. So if we understand sine, cosine should be very easy. Before we get into cosine though, I just want to emphasize our strategies for anytime we're given a graph, because this is going to be the same again for the cosine function. So this is what we just did with the sine function. If we are given the graph and we're trying to write the equation for the line, first identify the vertical shift. That's what we call our D value, remember? So we're going to look for the highest point and the lowest point, and then we find whatever is in the middle. That's the vertical shift. Sometimes you have heard me refer to that as the midline as well. Find the amplitude. So that's our A value. So remember that the distance from the vertical shift or the midline to the highest point, that's our amplitude. Remember, amplitude is always a positive value, but the A value, when I'm putting A in quotes, you can't see me doing my air quotes right now, that can be positive or negative depending on where we choose our starting point, which we're going to talk about in a second. The third thing is identifying the period. So find the distance of one complete cycle. Sometimes, depending on the graph and the information we're given, we might have to actually look at more than one cycle and divide by however far that was to find actually what one cycle is. Then the fourth thing, this is choosing our starting point. This is what we're going to designate our horizontal shift. So remember, from any given graph or curve that it could be a sine function, this will be true for cosine, there's an infinite amount of equations we could write. So we have to just pick what we want the horizontal shift to be. Now, anytime you have the opportunity to pick 0, if that's a possibility given the graph, then I would choose that. But if not, then you choose what you're going to pick your horizontal shift is, which is your starting point. Then our last thing is we're actually going to write the equation. So once we have all this information, we should be able to write the equation. And remember, we can write the equation with what we refer to as a B value. Again, there's my air quotes that you can't see, factored out. That is actually going to be usually easier to write the equation in that form, because then we can actually see the horizontal shift in the equation. But ultimately, it's up to you. All right, so let's do one more example of this, and then we will get into the cosine curve. So this problem says write a sine and cosine function for the following curve. Right now, we're just going to ignore the cosine part because we haven't actually talked about that yet. So we're just going to write a sine function. Now, again, there are an infinite amount of correct answers. So I want to think about, where do I see my image of one period of sine? And one place that I see that is right here, right? So that would be one period of sine. I also see that image if I start here and I go like this. I know that would be one period of sine. Or I could do a negative sine function. So those would both be what we would consider a positive sine function. So I could do this as well. That would be a negative sine curve. Any of these are going to be valid options. So most of these are going to have, or I'm sorry, all of these choices are going to have most of the same features. So the first thing, remember, our strategy was identify the vertical shift. And so if I see that the highest point on the graph is at 5 and the lowest point is at -1, I know that the midline is at 2. So I know my D value, or my vertical shift, is going to be +2. Now my amplitude, from there, I can see that the midline to the height, or if I went the midline to the lowest point, that's a distance of 3. So my A value is either going to be 3 or -3, depending on how I choose my starting value. So for right now, I'm just going to say my amplitude is 3 because that's always positive. The period is the distance of one complete cycle. So let's actually focus on the purple one that I drew, since that's the one that we can still see, and that's one complete cycle. So what is that distance? Well, if I start at -π/2 and then I go to +3π/2, that is a distance of 2π. So I know my period is going to be 2π. If the period is 2π, then the B value is 1. So then the last thing I have to do is I have to pick a horizontal shift, which is going to be my starting x value. Again, it doesn't matter which one I pick. I have identified 3 for us, so I could either choose negative 3 pi over 2, or I could choose negative pi over 2, or I could choose positive pi over 2. There are other choices also. I could pick positive 3 pi over 2, and I know there's other choices that aren't shown on this image, but that the graph would start at as well. So any of those 3 would be fine. Let's do 2 different examples. So what if I choose the negative 3 pi over 2? So if I say my horizontal shift is negative 3 pi over 2. So then I'm going to go ahead and write this equation. So if I choose the negative 3 pi over 2, that's a positive sine curve. So I'm going to say y equals, our a value is going to be 3 then. So 3 sine of, if I want to factor out my b value is 1. So just for the sake of understanding what this looks like, I'm going to write it like this, although the 1 is not necessary. Since it's negative 3 pi over 2, I'm going to do plus 3 pi over 2, and then our vertical shift was 2, so plus 2. So that is one correct answer. Another correct answer, let's go ahead and do the purple. So let's say that our horizontal shift is negative pi over 2. So if it's negative pi over 2, now almost everything is going to be the same, except for this is going to be a negative sine curve. So y equals negative 3 sine of 1 times the quantity x plus pi over 2, and then plus 2. So that is another correct answer. Again, we could have done the shifted pi half to the right. That would be correct as well. Okay, so now before we get into understanding the details of the cosine function, I want to look at how we started the sine function, which is unwrapping the unit circle, but now we're going to do this for cosine. So I've got a unit circle, but I also have a coordinate plane where I'm going to what we call unwrap the unit circle. So as I go around the unit circle, we're going to plot the cosine function. And remember, the cosine function is the x coordinates of the unit circle. So since when I'm at an angle of 0, the x coordinate is 1, that means that when I'm at an angle of 0 on the x-axis, the cosine output is going to be 1. So as I go around the circle, the y coordinates or outputs here, so let's just use the word output, that are being plotted are the x coordinates on the unit circle, because remember, those represent the outputs of the cosine function. And so this is where it gets confusing on x and y. I've got 2 different graphs going on here on the same image. So as I plot those values, so here we can see that we know at 90 degrees or pi halves, cosine has a value of 0, so it's going to have a value of 0. Right? And then as I go around, at pi, cosine has a value of negative 1. As I go around at 3 pi over 2, cosine has a value of 0 again. And then when I get back around at 2 pi, cosine has a value again of 1. So this image right here is one period of the cosine curve. And just to compare that, we know that this is one period of the sine curve, right? So this is the sine curve, the blue is the cosine curve. Those images, you want to kind of have that memorized. Just that picture in your head, what does one period of cosine look like and what does one period of sine look like? That'll make everything else much easier. But again, remember, it comes from the unit circle. Okay, so this I'm going to go through much quicker because, again, if we understood sine, it's actually the exact same. So first, our amplitude. Amplitude is the absolute value of a, and these are our generic cosine functions, and again, they're exactly the same as what we had for sine. The period is 2 pi over b, because the period of a basic cosine function is 2 pi. The intervals are the period divided by 4. The vertical shift is d, and the horizontal shift is c over b. But remember, we get that by saying bx minus c equals 0, bx equals c, so then x equals c over b. And that's where this is coming from. So those are our details for the cosine function. To graph a cosine curve, we're going to follow the exact same steps we did for the sine curve. The only difference is what the actual shape is going to look like. So if I have this information, I'm going to go, or this equation, I'm going to go ahead and find my information. So I know my amplitude is 2. The negative is going to affect the graph. I know that. The period is going to be 2 pi over b. In this case, b is actually pi over 2. So this will be 2 pi over 2. I multiply by the reciprocal. 2 over pi. 2 over pi. Those cancel. Those cancel. So the period is 4. Let's see. Vertical shift is none or 0. And horizontal shift is also going to be none or 0, because if I set this equal, I can do that for you, pi x over 2 equals 0, pi x equals 0, x equals 0. So I can write none or 0. Remember, that is my starting x value, and so now, similar to what I did with sine, I'm going to draw an axis. I'm going to label 9 marks. Oh, and I'm sorry, I forgot to do the intervals. So my intervals, if the period was 4, so the intervals are period divided by 4, so that is going to be 1. So this is going to be nice. I know this is 0, 1, 2, 3, 4, 5, 6, 7, 8. That's a 3. Sorry. My amplitude, or a value, was 2, so I'm going to call this 2, and I'm going to call this negative 2. The cosine curve, so remember I said memorize that image. The image normally looks like this, but since this is a negative cosine curve, it is going to flip. So a negative cosine curve is going to look like this. So my first point is going to be at the horizontal shift, x value, but at the maximum or minimum y value, because that's what the cosine curve looks like, as opposed to the sine curve is at the horizontal shift x value, and it's at the midline, or the vertical shift y value. So this is going to start down here, then I'm going to be in the middle, then up, then back in the middle, and then down. So that right there is one period of the cosine curve. Now I'm going to do that again. 1, 2, 3, 4, 5. That is 2 periods. That's it. That's cosine. Okay, I want you to actually try this one on your own, because again, if you can do sine, you should be able to do cosine. It just changes the shape. Pause the video, try this, unpause when you're ready to check. All right, here's my graph. Here's my information. Flip, no, because it's positive. Amplitude is 3, vertical shift is -1, period is pi over 2, because 2 pi divided by 4 is pi over 2. The intervals are pi eighths, because pi over 2 divided by 4 is pi eighths. Horizontal shift is pi fourths. There's my work. Label your axes. Start at the horizontal shift, count up by the intervals, and draw in your midline, your peak, your valley, and draw the shape for the cosine curve. Remember, make it look nice so it doesn't have to be to scale. Nice.